Okay, so here is the next topic, which is radioactivity, and that is a part of the chapter and small difference with that. Now, what exactly is radioactivity? Now, this is very interesting. When you say radioactivity, remember two things which are very, very important. When you say radioactivity, then as the name suggests radioactivity, it simple means that most of the time it's seen there are two kind of radioactivities we have it. One radioactivity is that is a natural, right? Natural radioactivity means there are some elements, maybe they have the atoms which have elements having their isotope, which are naturally a tendency of a radioactivity. They radiate some radiations out of them, and we call them radioactive elements. Now, important part is what exactly it means. We will talk about this in a minute. I'm talking about why there are some radioactive materials have a radioactive tendency, but those having atomic number, a big number like 1992 or something like that, if you're talking about 92 proton number, it means there are 92 protons and 92 electrons, plus they have neutrons as well. So being so big nucleus, very big nucleus, they are unstable in nature, right? Why they are unstable? Because there are multiple shells in which the electrons are evolving. So electrons are not that strong enough. And nuclear forces for them will be quite weak in that sense. So technically speaking, they are unstable in nature. Elements are unstable. The nuclei are nature. So what they do? They radiate different type of radiations so that they actually convert themselves into some stable nucleus. So the process of converting themselves from unstable nucleus into stable nucleus by radiating some of the radiations is called as radioactivity. This is a natural process as well, and this is by force as well. So what exactly is happening in that case? That some materials being radioactive material or something, they do radiate radioactive radiations, but some elements having atomic number more than 90 mostly, they are unstable in nature due to their size. And because due to their size, they want to convert themselves into some stable nucleus, or they try to radiate some of the radiations, which are called alpha, beta, and gamma radiation. We talk about them in a minute. What are those? And they radiate these radiations so that they convert themselves into atomic number lesser than what they have it. So they convert themselves into something very new element with new identity, everything. So that uh, decaying of an element into some, so that they want to convert themselves into stable nucleus is called as radioactivity. The process is called as radioactivity, while the substance is called as radioactive substance. Now, once you understand that, now we need to see that once the radiations which are emitted from the nucleus, from the radioactive substance, what type of substance or what type of radiations which are emitted from those radioactive substance. To study that, we do study that, and what we have found out that there are three kind of substances, or there are three kind of radiations which are emitted from these radioactive substances, which are called as alpha, beta, and gamma radiation. So what are those? Alpha, which is a sign of it, beta, this is a sign of beta, and gamma radiations. We do call it particles as well. Now, let's talk about the alpha particles first. The first important part is that what is alpha particle? Alpha particles are helium nucleus. And in this helium nucleus, you can say two electrons are being removed. It means helium has a +2 charge with two protons and four, you can say, nucleon. So this is the representation of alpha particles. Secondly, in an electric field, it always turns towards the negative electrode, or you can say it always turns towards the cathode. Why? Which shows that alpha particles are being positively charged particles. So alpha particles are positively charged particles, right? Next, the most important part is they are moving with this, they are moving with the speed 10% the speed of light, or 1 upon 10 of the speed of light. Like if you can simply say that whatever the speed is, they are moving with the speed 1/10 the speed of light. Being a heaviest particle out of alpha, beta, and gamma, they are moving with the speed of 1/10 the speed of light. Now, another very interesting thing is penetrating power. Being the heaviest of all, because these alpha particles are the heaviest amongst alpha, beta, and gamma radiations. So they have a very low penetration power. What happened? Even a small amount of air or a thin sheet of paper can easily stop it. All right. Then we have ionizing power. Now, ionizing power is mean by a power which actually converts, you can say that converts an atom into iron so that it will able to remove the electrons out of an atom. And being the heaviest and the strongest, they are easily converting an atom into iron because they can easily remove the electrons out of the atom. Next is magnetic field. When you pass this alpha particle through the magnetic field, they show deflection in the magnetic field. They show deflection in magnetic field. So that is what the properties of alpha particle. This is a sign of alpha. Next is beta. Now beta is very interesting. Okay, beta is very much interesting. Is it? So what is beta? When you say beta, what exactly is it? So what exactly is beta all about? Now, when you say beta, beta got two, three things into this. When are the beta particles are actually irradiated, or what happened? Beta sign is that. This is a sign of beta. That is what the sign of beta. It means that it has a charge of negative. And these are the fast moving electrons, which are actually comes out when the neutron changes into proton. Remember that. These are actually comes out when neutron converts into protons. Okay. Plus their sign is this E electron having negative charge, plus they have 0 nucleon. Now, in an electric field, they are always turned towards the anode, which means they have negative charge. Next is speed of light. They are moving with the speed, approximately moving with the speed of light, 90% the speed of light. Next is their penetration power. It's between alpha and beta. They cannot be stopped by the paper or air, but yes, few millimeter of aluminum and you can say few millimeter of metals like aluminum can easily stop it. All right. Next is definitely concrete and sheet of lead can easily stop. Now, moderate ionizing power. Again, being alpha particle being the heaviest, so they have a highest ionizing power. After that, beta particles have the moderate ionizing power, which is in between alpha and gamma. In the magnetic field, they also do deflection, but opposite to that of the alpha particle. Like, for example, if alpha particle shows deflection in the upward direction, they show deflection in the downward direction. And they deflection, you can say, being the heaviest, they deflection, alpha particle deflected less, but they deflected more. So their deflection line will be more. They deflect more. Now, next is gamma particles. Now, what are gamma particles? Gamma particles are just very high frequency electromagnetic radiations with no mass and nothing, and they are called their I mean their symbol is this. Now they are moving with the speed of light, right? Secondly, they are very highly penetrated. They cannot be stopped by anything. But yes, a concrete or steel, they can stop it and they can absorb it as well. Lowest ionizing power because they are least. In an electric field, it doesn't show any deflection. That's why they do not have any charge on that. In a magnetic field, they do not show any deflection at all. So these are the three kind of materials which are actually comes out of this radioactive radiations. Now, what are the effects of this alpha beta radiations once they come out from the different elements you can see here now? Now, check this out. This is very, very interesting. For example, this is radium, an element. It gives you an idea. Radium is 88, or let me show you further, because this is a bit like, but it not good. Now, if uranium 92 to 35 alpha particles are being emitted, you can see that proton number is reduced by 2, while a neutron or nucleon number is reduced by 4, and you have a helium nucleon, or you can say alpha particles are being emitted. So remember that your proton numbers will be removed by 2, and your nucleon number will be removed by 4 in that. So uranium converts into thorium along with the alpha particles. Same thing here, radium. Radium's 88 to 23 is converted into 86. So proton number reduced by 2, while 223 is reduced to 219, means reduced by 4. So nucleon number is reduced by 4, while proton number is reduced by 2 along with the helium nucleus. Same thing, americium. You can see that proton number is reduced 95 to 93, so by 2, and uh, nucleon number 243 is reduced to 239, so reduced by 4 along with the helium nucleus. So whenever helium is released, number is reduced by 2, while nucleon number is reduced by 4, right? Now the second important thing, beta. Now remember that we only have beta negative minus decay. There is a beta positive as well, but it's not in our code. Whenever beta particle is being released, electron is originated with, and your proton number will be increased by one. Like here, you can see yourself, carbon 6 is converting into nitrogen 7, while proton number for both of them will be same. But remember one thing, this is very, very important, because proton converts into neutron, right? Because in this case, you can say neutron proton ratio from 8:6 to 7:3, which means in beta minus decay, a neutron in the nucleus changes spontaneous into proton. So technically speaking, here we have 6 proton. Let's calculate it and see yourself. 14 minus 6, which is 8. So 8 neutrons and 6 protons. While in the neutron, nitrogen, you got 7 protons and 7 neutrons. So as far as the nucleon number is concerned, it will be same, because it will be proton plus neutron. But as far as proton is concerned, proton is increased by 1, but neutron will be reduced by 1. Okay. So this is by Evans, there is a decay in that manner. See, cobalt 27 converts into nickel 28, along with one you can say one beta particle. Same thing happened. Proton is increased by 1, while number of neutron is reduced by 1. Proton and neutron remains the same. Same thing happened with the radium and all. So this is what the equation of alpha, beta, and gamma. Now remember that in case of gamma, the equation remains the same because it doesn't affect on anything, right? It doesn't affect anything on that. So this is what the point is. Now let's quickly go through some of the, you can say, dangers for that, and also some of the advantages of that. Now, first, very important thing, some of the, you can say, issues are, or you can say dangers of the thing are, which we will have to discuss. Now, there are different, uh, so for the, we have to discuss the dangers in everything. Plus, we will have to discuss the background radiation and all that topic, and how do we actually extract that. That is a topic of our next video. This, so we will stop it here. In this video, we have discussed the radiations. Plus, we discussed alpha, beta, and gamma radiation properties. And next video, we will see their advantages, their not advantages, their uses, their dangers, and their precautions, plus background radiation and few more topics relevant to that. So hope to see you in the next video, which will be our 23rd video. Thank you for watching. Bye.